we will explore how to build an artificial neural network, ANN, using the NET package in R. Artificial neural networks are powerful tools for data processing and learning. First, we will install and load the NET package. After installing the package in RStudio, we will load it. Next, we will generate example data. The dataset will consist of 2 input variables and 1 class label. We will prepare the data to be used for training the neural network model. We will normalize the range of each input data to be between 0 and 1. This process is very useful for neural network training. Normalized data maximizes the learning effectiveness of the model. Now we will train the ANN model. We will set the model using the 2 input variables, x1 and x2, and configure it with 5 hidden nodes. This model will perform predictions based on the input data. Once the model training is complete, we will summarize the structure of the model. The summarized information will provide us with the number of nodes in each layer and the weight information. Next, we will generate data to predict in the same format as the training data. We will prepare prediction data to proceed with the model validation process. Using the normalized new data, we will perform predictions. The prediction results will be classified and output as 0 and 1. This step is crucial for evaluating the effectiveness of our model. We will output the prediction results. This will allow us to check the predicted class labels generated by the model. We can evaluate the model's performance by comparing it to the actual classes. To evaluate model performance, we will create a confusion matrix. The confusion matrix is useful for measuring performance by comparing the model's predictions to the actual results. Now it's time to calculate the accuracy. We will check how accurate the model's predictions are and assess the agreement between the actual classes and the predicted classes. Accuracy is an important metric of model performance. In this video, we have built a simple artificial neural network model using R's NET package and performed predictions. Artificial neural networks are widely used in various fields and can be utilized alongside deep learning frameworks like Keras, which offer more advanced features and complex structures. References. The model summary provides a summary of the 251 structure of the artificial neural network. This network consists of 2 input nodes, 5 hidden nodes, and 1 output node. The weights between each node are defined as follows. The weights between input nodes and hidden nodes represent the weights coming from the bias to each node. There are also weights between the output node and the hidden nodes. These weights are optimized during the training process of the network and have a significant impact on the model's performance and prediction accuracy. The artificial neural network, ANN, is a branch of machine learning that mimics the structure of the brain's neural networks. There are various types of artificial neural networks, and their performance and characteristics can vary depending on how these networks are implemented and the tools used. Differences between Keras and NET. Keras is a high-level deep learning API built on top of low-level machine learning frameworks like TensorFlow, Theno, and Microsoft Cognitive Toolkit, CNTK. It helps create and train complex neural networks easily with a user-friendly and modular structure. On the other hand, NET is a simple artificial neural network library used in the R language, primarily implementing a multi-layer perceptron structure for regression and binary classification. Compared to Keras, it provides a simpler and easier-to-use API but has limited functionality. In this way, Keras and NET differ in their characteristics and purposes, and the choice of tool will depend on the project's requirements, the size, and complexity of the data. The R code is posted in the community post.